Hello everyone. Let's take a look at a proof for one of our converses. This theorem states that if the opposite sides of a quadrilateral are congruent to each other, then that quadrilateral is a parallelogram. So this gives us a way to start with a quadrilateral, and as long as we know some properties about it, we can determine whether or not it is a parallelogram. So here I have just a quadrilateral. We don't know if this is a parallelogram yet. That's what we are going to show. So my given information is that the two pairs of opposite sides are congruent to each other. So we know that AB is congruent to CD, and we also know that the other pair of parallel sides, we know that BC is congruent to AD. So that's what we get to start with, and we want to show that this is a parallelogram. The way that we have to do that is by using the definition of a parallelogram, which is that the opposite sides are parallel to each other. So let's start our proof with our given information as usual. So it is given that the two pairs of opposite sides are congruent, so we know that AB is congruent to CD, and we know that our other pair, BC, is congruent to AD. Okay. Now, from there, the next thing I want to do is I actually want to split this up into two triangles. So I'm going to draw in a diagonal. As long as I have 2 points, I can connect them together with a segment. This is going to split up this triangle, or this quadrilateral, into 2 triangles. And my general plan of attack is I want to show that these triangles are congruent to each other. And then I can use corresponding parts to show that the angles are congruent, and then I can get the sides parallel. So, draw a diagonal, and we went from B to D. So that created the 2 triangles. I already know that 2 of the pairs of the sides match up for these triangles. So if I can get that third pair of sides, we know that they're congruent, which that shared segment is congruent to itself. So we know that BD is congruent to BD by the reflexive property. And that gives me 1, 2, 3 pairs of congruent sides. So we know that then triangle ABD is congruent to triangle CDB by side, side, side. Okay. So that takes care of the first part, getting the 2 triangles congruent. Now that I know the triangles are congruent, I know that their corresponding parts have to match up as well. So that means that these angles within these triangles have to be the same. So for example, this angle here, so ADB, that has to be congruent to the corresponding angle up here, which is this one. So we know that angle ADB is congruent to triangle CBD, or sorry, angle CBD. And also, if we look at a second pair of angles, we know that angle ABD, this angle here has to match up with that angle there. So angle ABD is congruent to angle CDB. And as you've seen many times, whenever I know that some angles are congruent like this, if we have these angle relationships, so this is going to lead me to some parallel sides. So, because CBD and angle ADB are congruent, that gives me a pair of alternate interior angles. That makes AD parallel to BC. So we know AD is parallel to BC because of that pair of alternate interior angles. And using the other pair of angles we have, so now I'm looking at this pair of alternate interior angles going this way. So AB is parallel to CD, and that is the alternate interior angles converse. And finally, because the two pairs of opposite sides are parallel to each other, that's our definition of a parallelogram. So let's finish up by saying, therefore, ABCD is a parallelogram, and that is just the definition. And that's what we wanted to show. So, starting off by knowing that the opposite sides are congruent, we were able to determine that yes, it is in fact a parallelogram.